Welcome to our comprehensive React development course. Whether you're a beginner looking to dive into the world of React or an experienced developer seeking to deepen your knowledge and skills, this course is designed to provide you with a thorough understanding of React fundamentals, advanced topics, and best practices. Throughout this course, you will embark on an enriching journey through the various aspects of React development, from understanding the core concepts to exploring advanced techniques and building real world projects. By the end of this course, you'll have the skills and confidence to create robust, efficient, and maintainable React application. Hello, I'm Vivin Arana, and I'll be walking you through this course. What will you learn in this course? First, React fundamentals. Gain a solid understanding of React's core concepts, including components, state management, props, and JSX syntax. Advanced React topics. Explore advanced topics such as React hooks, context API, server side rendering, SSR, and performance optimization techniques. Styling and UI design. Learn different approaches of styling in React, including CSS modules, inline styles, and CSS in JS libraries like styled components. State management. Understand various state management solutions in React, including local state, global state with Redux, and context API. Routing and navigation. Master the art of routing and navigation in React applications using React Router to create dynamic multi-page experiences. Deployment strategies. Learn how to optimize and deploy React applications to popular hosting platforms like Netlify, Vercel, and Heroku. How to use this course. This course is structured to provide you with a step-by-step learning experience starting from the fundamentals and gradually progressing to more advanced topics. Each session is carefully crafted to explain concepts in detail, accompanied by practical examples and hands-on exercises to reinforce your understanding. We encourage you to actively engage with the course material, complete the exercises, and apply what you have learned to real world projects. Don't hesitate to reach out to fellow learners or instructors if you have any questions or need clarifications on any topic. You can also leave comments in this video down below. So, without further ado, let's embark on the exciting journey into the world of React development. Get ready to level up your skills and build amazing React applications. Happy coding! Introduction to React. What is React? React is a JavaScript library for building user interfaces. It was developed by Facebook and released as an open source project. React allows developers to create reusable UI components that can efficiently update and render changes to the user interface when data changes. Why use React? React has gained immense popularity among developers for several reasons. Declarative syntax. React uses a declarative syntax, making it easier to understand and write code. Developers can describe what the UI should look like, and React handles the underlying updates and rendering. Component based architecture. React follows a component based architecture, allowing developers to create reusable and encapsulated UI components. This modular approach makes it easier to maintain and scale applications. Virtual DOM. React utilizes a virtual DOM document object model to improve performance. Instead of directly updating the actual DOM, React updates a virtual representation of the DOM and then efficiently applies the changes to the real DOM, reducing unnecessary re-renders and improving performance. One-way data binding. React follows a unidirectional data flow, which means data flows in a single direction from parent to child components. This makes it easier to manage the state of the application and reduces unexpected side effects. Rich ecosystem. React is a vast ecosystem of tools, libraries, and community support, making it easy to integrate with other technologies and extend its functionality. Key features and benefits. Component reusability. React allows developers to create reusable UI components, enabling efficient development and maintenance of applications. Virtual DOM. React's virtual DOM improves performance by minimizing unnecessary updates to the actual DOM, resulting in faster rendering and better user experience. Unidirectional data flow. React follows a unidirectional data flow, making it easier to manage application state and reducing the likelihood of bugs. JSX syntax. React uses JSX, JavaScript XML, a syntax extension that allows developers to write HTML-like code with JavaScript. This makes the code more readable and easier to maintain. React Native. React can be used to develop native mobile applications through its companion framework React Native. This enables developers to build cross-platform mobile apps using familiar React components, concepts, and components. Setting up a React development environment. To start developing with React, you need to set up a development environment. Follow these steps. First one, Node.js installation. React requires Node.js and npm, Node Package Manager, to manage dependencies and build the project. You can download and install Node.js from nodejs.org. Create a React app. Create React app is an official React tool that sets up a new React project with a sensible default configuration. To create a new React app, open your terminal or command prompt and run the following command: npx create-react-app my-react-app. Replace my-react-app with the name of your project you want. Navigate to the project directory. Once the project is created, navigate to the project directory using the following command: cd my-react-app, again the name of the app that you used. Start the development server. To start the development server, run the following command: npm start. This command will start the development server and open your default web browser to display the React app. Next, begin coding. You are now ready to start coding your React application. Once, open your preferred code editor and start editing the files in the src directory. React will automatically reload the page whenever you make changes to the code. So go ahead, play with it. So in this tutorial, we introduced React, discussed its key features and benefits, and guided you through setting up a React development environment. With React, you can build powerful and interactive user interfaces for web and mobile applications efficiently. Happy coding! Getting started with JSX. What is JSX? JSX, also called as JavaScript XML, is a syntax extension for JavaScript, commonly used with React. It allows developers to write HTML-like code with JavaScript, making it easier to describe the structure of UI components. JSX is not a separate language, it's just syntactic sugar for function calls and object creation. Here's an example of JSX code. Constant element equal to h1, hello, JSX h1. In the above code, h1 hello JSX slash h1 looks like HTML, but it's actually a JSX expression that gets transformed into JavaScript. Integrating JSX into your React project. Integrating JSX into your React project is straightforward. When you create a new React project using Create React App or another boilerplate, JSX support is already included. Here's how you can include JSX in your React components. Create a new React component, for example, myComponent.js file. Write your JSX code within the component's render method or directly within the component if it's a stateless functional component. Import React at the top of your file as JSX needs to be transformed into React elements using something like this: import React from React. Writing JSX expressions and components. In JSX, you can write expressions within curly braces to embed JavaScript expressions or variables. This allows you to dynamically generate content within your JSX code. Here's an example of using JSX expression. Creating a constant name, John Doe, constant element equal to h1 hello, and then inside the curly brackets use the name. JSX also allows you to create reusable UI components. Components are like JavaScript function that return React elements. Here's an example of a simple functional component return in JSX. Function welcome props. Return h1 hello props.name h1. You can then use this welcome component within other JSX code by calling constant element equal to welcome is the name of the function, and name equal to John, which is the props which it will take inside and print that name in next to hello. JSX versus HTML. While JSX resembles HTML syntax, there are some key differences. The attributes. JSX uses camel case for attribute names similar to JavaScript. For example, class in HTML becomes class name in JSX. Style attribute. In HTML, the style attribute accepts a string. In JSX, the style attribute accepts an object with camel case properties. Self-closing tags. In JSX, self-closing tags must have a trailing slash similar to XHTML, image slash, input slash, etc. Comments. JSX uses JavaScript style comments enclosed in curly braces and prefixed with double slash or enclosed in slash star star slash. Here's an example comparing HTML and JSX. So if we look at HTML here, we have div class container and we put a paragraph tag with hello world inside it and close the div. In JSX, we say we don't have class, we have class name equal to container and p hello world. In summary, JSX is a powerful tool that simplifies the creation of UI components in React by allowing developers to write HTML-like syntax directly within JavaScript code. It provides a more concise and expressive way to describe the structure of UI components compared to plain JavaScript or HTML. Components and props. First, let's go over understanding components in React. In React, components are the building blocks of a user interface. They encapsulate the behavior and appearance of a part of the UI, making it easier to manage and reuse code. Components can be either functional or class-based. Let's look at creating functional and class components. Functional components. Functional components are JavaScript functions that accept props, short for properties, as an argument and return JSX to describe the UI. They are typically used for simpler components that don't need state or lifecycle methods. Check out this example where I'm creating a functional component. The function name is greeting and props as the argument, and it returns hello and passes back props.name inside curly brackets, which will be substituted by whatever was passed in the argument. The class components. Class components are ES6 classes that extend React.component. They have a render method that returns JSX to describe the UI. Class components are used for more complex components that need to manage state or lifecycle methods. Here is an example, same class greeting, and we are saying extends React.components. And inside the class, we are saying render, call the render function, which returns the HTML with hello, and then you're using this dot props dot name. Passing props to components. Props are a way to pass data from parent to child component in React. They are read-only and cannot be modified by the child component. Props are passed as attributes to the component when it's used. In this example, you can probably see here the parent component, which is the app, passes the name prop to the child component using greeting. The child component then uses this prop to display a personalized greeting. Again, if you go step by step, function app, which is the parent component, returns greeting. Now this greeting comes from the next function, which is the child component, where you're passing the props, which is name equal to John in the second line, and that returns, the child returns the HTML hello and passes the props.name, which is John. So the output of this will be hello John. Reusable components and component composition. One of the key benefits of React is the ability to create reusable components. By designing components to be modular and composable, you can build complex UIs from smaller reusable parts. If you look at this example, the button component is reusable and can be used in various parts of the application. The app component composes the button component by passing custom props on click and label, making it flexible and reusable in direct context, in different contexts. If you look at here, we have the function button, which is the button component, which returns on click and has the props label in there. Now the application can call the handle click but function inside it, where it will just console log button clicked, and if you see, the return for that function is passing the button on click and label function. In summary, components are fundamental building blocks of React applications. Whether functional or class-based, components allow you to create modular, reusable, and maintainable UIs. Props enable data flow between components, while component composition enables the creation of complex UIs from smaller reusable parts. State and lifecycle. Let's go over understanding state in React. State is a built-in feature of React that allows components to keep track of mutable data. It represents the current condition of a component and can be changed over time in response to user actions, network responses, or other events. Stateful components are components that manage their own state. Next, managing state with class components. In class components, state is initialized in the constructor and accessed via this.state. To update state, you use the setState method provided by React. When state changes, React automatically re-renders the component to reflect the updated state. In this example, the counter component manages its own state with the count property. Clicking the increment button updates the state, causing the component to re-render and display the updated count. So if you go through this example here, we have the class counter extends react.component. It has the constructor props where it's setting this dot state count equal to 0. Next, if you look at the increment count function, this dot set state, it increments that state's count by 1. And finally, the render function, which renders the HTML for that particular counter and the button. Lifecycle methods in class components. Class components have a set of lifecycle methods that are invoked at different stages of a component's lifecycle. These methods allow you to perform actions such as initializing state, fetching data from a server, or cleaning up resources. Some common lifecycle methods include component did mount. It's invoked after the component is mounted, inserted into the DOM. This is a good place to perform initial setup such as fetching data from an API. Next, component did update, which takes two arguments, previous props and previous state, invoked after the component is updated. This is where you can perform side effects in response to prop or state changes. Next one, component will unmount. This is invoked immediately before the component is unmounted and destroyed. This is where you can clean up any resources or event listeners created by the component. Updating state and re-rendering components. In React, you should never modify state directly. Instead, use the setState method provided by React to update state. When you call setState, React merges the updated state into the existing state and schedules a re-render of the component. If you look at this example, clicking the button toggles the is toggle on state between true and false. React automatically re-renders the component with the updated state, updating the button text accordingly. If you look at it here, we have the render function. We have the class toggle, which has the is toggle on inside the set state to be set true. Now, the way we handle click function is we are saying that is toggle is not equal to previous state dot is toggle on. So if it's true, it's set to false. If it's false, that's what toggle does. That's what you assign to this dot set state and pass the previous state in there. In summary, state and lifecycle methods are essential concepts in React for managing dynamic data and performing actions at different stages of a component's lifecycle. By understanding how to manage state and utilize lifecycle methods effectively, you can build robust and interactive React applications. Handling events in React. Event handling in React. In React, handling events is similar to handling events in regular HTML, but with a few differences due to the use of JSX and the fact that event handlers are attached using camel case naming conventions. Binding event handlers. When using class components in React, it's important to bind event handlers to the component instance. This ensures that this inside the event handler refers to the component instance, allowing you to access the component's method and state. In this function, the handle click method is bound to the component instance in the constructor using bind this. If you look at the fourth line, where inside the constructor we are saying this dot handle click equal to this dot handle click dot bind this. That's how you bind inside the constructor. Passing arguments to event handlers. You can also pass arguments to event handlers in React by using arrow functions or bind. This allows you to customize the behavior of the event handler based on the context in which it's called. If you look at this example, we have the class button, we have the render function, handle click with the argument passed to it. You see, an arrow function is used to pass the argument hello to the handle click with argument method when the button is clicked. You see that inside the button on click, and you have the empty anonymous function which is passing the arrow function. Common event handling patterns. Prevent default behavior. To prevent default behavior of an event, example submitting a form or following a link, you can call prevent default on the event object. If you see in this example, in the function handle submit, the first line is event.prevent default. So it stops the form being submitted when you press the click button. Stop event propagation. To stop the propagation of an event, that is, prevent it from bubbling up the DOM tree, you can call stop propagation on the event object. So in this example, again, when on click is called, we call the handle click function, which does the stop propagation. In this example, clicking on the button will only log button clicked to the console, as the stop propagation method prevents the click event from bubbling up to the container div. Handling events in React is essential for building interactive and dynamic user interfaces. By understanding event handling patterns and how to bind event handlers in React components, you can create powerful and responsive applications. Conditional rendering in React. For conditional rendering in React, it allows components to render different output based on certain conditions. This enables developers to create dynamic and interactive user interfaces where components can change their appearance or behavior based on the application state or user interactions. Using conditional statements in JSX. In JSX, you can use standard JavaScript conditional statements such as if, else, and switch to conditionally render elements. These statements can be used inside curly braces to evaluate expressions. In this example, the greeting component renders a different message based on the value of the isLoggedIn prop. So we get the isLoggedIn constant and we pass the isLoggedIn to that. And depending on isLoggedIn, we return welcome back, or if the user is not logged in, where isLoggedIn is returning false, we say return false login. Please log in. Ternary operators and logical and operator or and operator. Ternary operators, which is condition question mark to true, or which is colon false, And the logical and operator can also be used for conditioning render in JSX, providing a more concise syntax for simple conditions. If you look at both the examples above, the is logged in variable is used to conditionally render different JSX elements based on its value. So the first one where it's returning is logged in, if the user is logged in, it will say welcome back or it will say please log in, which is similar to previous example. But instead of using the if else, we are using the ternary operator. Whereas in the second app greeting function, where what we are doing is we're checking is logged in and if it's true, then we say welcome back. If not, then we say please log in using the and in this case we are saying not is logged in. So depending on which property is true, it will print out that particular HTML. Rendering lists of data dynamically. React provides the ability to render lists of data dynamically using the map function to iterate over an array of data and generate a list of elements. In this example, the to-do list component, it receives an array of to-dos as a prop and dynamically renders a list of li elements for each to-do item using the map function. So if you look at the return, it will go over each and every item using the map function to display the li HTML for each and every to-do item. Conditional rendering is a powerful feature in React that allows components to adapt their output based on dynamic conditions. By using conditional statements, ternary operators, and the logical and operator, developers can create flexible and interactive user interface. Additionally, rendering lists of data dynamically enables the creation of dynamic and data-driven UIs in React applications. Forms and controlled components in React. Handling forms in React. In React, handling forms involves capturing data entered by users and managing that data within the component state. This allows developers to create interactive and dynamic forms where user input can be processed and validated. Controlled versus uncontrolled components. Control components. In control components, form elements such as inputs, selects, and text areas are controlled by React state. The value of the form element is stored in the component state and React handles the updates to the value. Uncontrolled components. In uncontrolled components, form elements maintain their own state and React doesn't control their values. Instead, developers typically use refs to access the form element's value when needed. Control components are typically preferred in React because they provide a single source of truth for the form data, making it easier to manage and manipulate data. Updating state with form inputs. To update state with form inputs in controlled components, you need to handle the onChange event for each form element and update the corresponding state property. In this example, the handle change method updates the state whenever the value of the input element changes, and the handle submit method logs the form data when the form is submitted. If you look at this class myForm, which extends component, the React component, have the constructor here where state is set for username and password to be empty. Whenever the handle change, as we mentioned, the name is set to the event target value, and similarly handle submit, we are just submitting, we're preventing the default and which is submitting the form, and we just console log the state of the form. And if you look at the HTML element, we have on submit event which calls the handle submit button, the handle submit function, and then we have the to input and the button elements, where inside the input we are setting the value of the text and password to the state's username and password. Form validation and error handling. Form validation is the process of ensuring that user input meets certain criteria or constraints before submitting the form. React provides various techniques for form validation such as conditional rendering, input validation, and validation libraries like Formic or Yep. In this example, you'll see the form is validated by checking if the email and password fields are empty. If there are validation errors, error messages are displayed below the corresponding input fields. So if you see in here in the return element inside the render function, we have the input elements. Below that, we have the error messages which will be displayed if there's errors. And that is handled by when the handle submit is pressed, handle submit function is called. We have the if else or if functions, if loops to check if the email password or if passwords are there, and if there's any errors, we are probably gonna show that. If not, if there's no error, then we'll just saying form submitted. Forms and control components play a crucial role in React applications, allowing developers to create interactive and dynamic user interfaces. By understanding how to handle forms, update state with form inputs, and perform form validation and error handling, you can build robust and user-friendly forms in React applications. React hooks. Let's go over the introduction to React hooks. React hooks are functions that allow developers to use state and other React features in functional components. Prior to the introduction of hooks, state and lifecycle methods were only available in class components. Hooks provide a way to use state and other React features without writing a class. Let's go over some of the common ones, which is useState, useEffect, and also we'll look at other built-in hooks. The useState allows functional components to have state. It returns a stateful value and a function to update that value, similar to this.setState in class components. UseEffect allows functional components to perform side effects such as data fetching, subscriptions, or manually changing the DOM after rendering. It serves the same purpose as lifecycle methods like component did mount, component did update, and component will unmount in class components. React also provides several other built-in hooks like use context, use reducer, use callback, use memo, and use ref for different use cases. Writing your custom hooks. Custom hooks are functions that use built-in hooks to encapsulate reusable logic. They allow you to abstract complex logic into reusable functions that can be shared across multiple components. In this example, useFetch is a custom hook that fetches data from a given URL using fetch and updates state accordingly. In return, it returns an object containing the fetch data and a loading indicator. So in this function, we probably say useFetch is what we are using, where we are using useEffect inside it to fetch the data using the async function, and once that is fetched, we provide it back, returning using data and also the loading parameter. Refactoring class components to functional components with hooks. Class components can be refactored into functional components with hooks. Here's an example of refactoring a class component in a functional component using useState and useEffect. In this example, the timer component is refactored from a class component to a functional component using useState to manage state and useEffect to update the timer every second. So go through this example, you'll probably see how useState and useEffect is used. React hooks provide a more concise and expressive way to manage state and other React features in functional components. By understanding built-in hooks like useState and useEffect, as well as writing custom hooks, developers can create more reusable and maintainable code. Additionally, refactoring class components to functional components with hooks can improve code readability and reduce boilerplate. Routing with React routers. Let's go with the introduction to React router. React Router is a popular library for adding routing functionality to React applications. It allows developers to create single-page applications with multiple views, each corresponding to a different URL. React Router provides a declarative way to define routes and handle navigation within a React application. Setting up the routes in React applications. To use React Router in your application, you first need to install it via npm. You can do that by npm install react-router-dom. Then you can set up routines in your application by wrapping your root component with the browser router component and defining route components for each route. In this example, we define three routes: slash, slash about, and slash contact, each rendering a different component when the corresponding URL is matched. So for example, when the route exact path equal to slash, it will open the component home. Same for slash about, it will open about. Slash contact, it will open contact. Navigation between routes. React Router provides several components for navigating between routes, such as link and navlink. In this example, we use the link component to create links to different routes in our application. For example, you say link to slash is home, link to slash about is about, link to slash contact to the contact page. Nested routes and route parameters. React Router supports nested routes and route parameters, allowing for more complex routing scenarios. In this example, we define nested routes for a slash products route and with a nested route for displaying product details based on the ID route parameter. So if you see here, slash products is pointing to component products, which is below, defined in a function products, which has slash products and slash product colon ID, which depends on what ID is passed, it will open that particular product details. React Router is a powerful library for adding routing functionality to React applications. By setting up routes, handling navigation, and leveraging features like nested routes and route parameters, developers can create dynamic and interactive single-page applications with multiple views and URLs. State management with Context API. Introduction to Context API. The Context API is a feature introduced in React that allows components to share data without having to pass props manually through each level of the component tree. It provides a way to pass data through the component tree without having to explicitly pass props down the tree at every level. Creating and consuming context. Creating context. Context is created using the create context function from the React module. We can do that by import React from React and then constant my context equal to react.create context. This is how you can create a context. Providing and consuming a context. To provide context to components, wrap the parent components with the context.provider component and pass the data as a value prop. So if you see here, you have my context.provider where value is some value, and then you have child components under it and close the my context.provider. To consume context in a child components, use the context.consumer component or the use context hook. So if you see here, my context.consumer value equal to whatever value you want to render something based on the context value and then close it. And the other way is to use context, where you can say in code in my component has a constant value equal to use context my context. Using context to manage global state. Context can be used to manage global state by providing state values through context and dating them in the higher level components. So in this case, you see I have my context where I'm creating the context, and I am calling in the my provider component where I am getting the state and set state from use state, and then I'm returning the my context.provider, passing it the value of state and set state and prop children inside it, all the children components inside it, and closing it. Context versus Redux for state management. Both Context API and Redux are state management solutions for React applications, but they serve different purposes and have different use cases. For Context API, it is suitable for managing simpler state that needs to be shared between components in a smaller application or specific parts of a larger application. It's built into React and doesn't require any additional libraries. Redux is suitable for managing complex state and handling asynchronous actions in larger applications. It provides a centralized store and allows for more structured and predictable state management. It's often preferred for large applications with many interconnected components. In summary, Context API is a simpler and more lightweight solution for state management in React applications, while Redux provides more advanced features and scalability for larger and more complex applications. The choice between the two depends on the specific requirements and complexity of the application. Styling in React. Styling options available in React. When it comes to styling in React, there are several options available, each with its own advantages and use cases. Some common styling options include inline styles, where you apply styles directly to the JSX elements using the style attribute. There is CSS modules, where you use CSS files with local scope, allowing for better encapsulation and avoiding class name conflicts. CSS in JS libraries use JavaScript to generate style dynamically, often scoped to specific component or elements. CSS preprocessors use preprocessors like Sass or Less to write CSS with additional features such as variables and mixins. Inline styles. Inline styles allow you to apply CSS directly to the JSX elements using the style attribute. Styles are defined as JavaScript objects with keys representing CSS properties and values representing their values. In here we have my component, and inside that I have the div style, which has color red and background color light blue, and inside the div HTML element you see the style is been assigned as div style over there. Inline styles are scoped to individual elements and can be dynamic, allowing for conditional styling based on the component state or props. CSS modules. CSS modules allow you to write CSS files with local scope, ensuring that styles only apply to specific components. Each CSS file is automatically scoped to the component importing it, avoiding class name conflicts. So, for example, in let's say styles.module.css file, you're creating a my button style, you give the background color and the color, and inside your code you say import styles from styles.modules.css, and in here you can, for the button, you can provide a class name equal to styles.mybutton that will use, so the button will use the style above. CSS modules provide better encapsulation and maintainability compared to the global style sheets, as styles are only applied where they are imported. Next, CSS in JS libraries like styled components. CSS in JS libraries like styled components allow you to write CSS directly in your JavaScript code, often scoped to specific components or elements. This allows for dynamic and expressive styling with features like props-based styling and theme support. If you see here, we have our import style from style-components. Then we create a constant style button, and this is style button background color. We provide some props to it, and then color we provide some props to that. Now inside your function, you create the style button and you set it as primary, and based on the style it will accordingly style the button. Style components generate unique class names for each styled components, ensuring that styles are scoped and isolated from other components. Styling in React offers a variety of options to suit different preferences and project requirements. Inline styles provide simplicity and flexibility. CSS modules offer encapsulation and scoping, and CSS in JS libraries like style components provide dynamic and expressive styling capabilities. The choice of styling methods depends on factors such as project size, team preference, and desired features. Deploying React applications. The build process for React applications before we deploy. Before deploying a React application, it's essential to build the project to produce optimized production ready files. This involves transforming JSX syntax, building JavaScript files, and optimizing assets for performance. To build a React application, you can use the npm run build command, which is provided by create React app CRA and other React project templates. This command creates a build directory containing all the optimized production files. So all you have to do is like run this npm run build command. Optimizing and bundling your React app. During the build process, various optimizations are applied to ensure that the React application performs efficiently in a production environment. Some common optimizations include minification. Now, JavaScript, CSS, and HTML files are minified to reduce their size by removing unnecessary white space and comments. Bundling. Multiple JavaScript files are bundled together into a single file, reducing the number of HTTP requests required to load the application. Code splitting. Large JavaScript files are split into smaller chunks, allowing for lazy loading of code and faster initial load times. Tree shaking. Unused code is removed from the bundle, reducing the overall file size and improving performance. Now, deploying React apps to hosting platforms. Once the React application is built and optimized, it can be deployed to a hosting platform to make it accessible to users over the internet. Some popular hosting platforms for deploying React applications include Netlify, a popular platform for deploying static websites and web applications. It offers continuous deployment, automatic SSL, and easy integration with Git repositories. Vercel, formerly Zit now, another platform for deploying static and server rendered applications. It provides features like automatic deployment, serverless functions, and global CDN. Heroku, a common platform that supports deploying various types of applications, including React apps. It offers a flexible deployment process and scaling options. To deploy a React application to one of these hosting platforms, you typically need to create an account on the hosting platform, connect your Git repository to the hosting platform, then configure deployment settings, example, build commands, environment variables, then trigger the deployment process, often done automatically on each Git push. Deploying React application involves building and optimizing the project, followed by deploying it to a hosting platform where it can be accessed by users. By following the build process and choosing a suitable hosting platform, you can make your React application available to a wide audience on the internet. Best practices and tips for React development. Now let's go over the React best practices first. The first one is component structure. Organize your components based on their functionality and reusability. Use functional components whenever possible and keep them small and focused. State management. Prefer using local state, which is use state, for component specific state and global state management solutions like Redux or the context API for managing application wide state. Props usage. Keep props immutable and avoid modifying them directly within components. Use props to pass data from parent to child components. Lifecycle methods. Understand the React component lifecycle and use lifecycle methods like useEffect for functional components appropriately for handling side effects, data fetching, and cleanup. Conditional rendering. Use conditional rendering techniques like ternary operators or logical and for rendering components conditionally based on state or props. Error handling. Implement error boundaries to gracefully handle errors in React components and prevent the entire application from crashing due to a single error. Keys in list. Always provide a unique key prop, two elements in list to help React identify which items have changed, added, or removed, improving rendering performance. And let's go over some tips for writing efficient and maintainable React code. Keep your components small. Break down complex UIs into smaller reusable components to improve code readability and maintainability. Use functional components. Whenever possible, use functional components over class components as they are simpler, more concise, and easier to understand. Avoid nested ternary operators. Limit the use of nested ternary operators to avoid code complexity. Instead, consider using conditional rendering with if statements or switch cases for better readability. Use memoization. Utilize the use memo hook to memoize expensive calculations or complex data transformation to improve performance by avoiding unnecessary re-renders. Destructuring props and state. Destructure props and state within functional components to improve code readability and avoid repetitive props and state references. Consistent naming conventions. Follow consistent naming conventions for components, props, and state variables to make the code base easier to understand and maintain. Code reviews and refactoring. Conduct regular code reviews and refactorings to identify and fix code smells, improve code quality, and adhere to best practices. Performance optimization techniques. First one, lazy loading. Use code splitting and lazy loading to load components and routes asynchronously, improving initial load times and reducing bundle sizes. Debouncing and throttling. Implement debouncing and throttling techniques for event handlers and data fetching to reduce unnecessary function calls and network requests. Memoization. Memoize expensive calculations and functions result using the use memo hook to prevent unnecessary recalculations and improve rendering performance. Virtualization. Implement virtualization techniques like windowing or infinite scrolling for large lists or grids to optimize rendering performance by rendering only the visible items. Optimize images. Optimize images for the web by compressing them using modern image formats, example WebP, and lazy loading images to improve page load times. Bundle analysis. Analyze and optimize the size of the application bundle using tools like Webpack, Bundle Analyzer to identify and eliminate unnecessary dependencies and reduce bundle size. Server-side rendering (SSR). Consider implementing server-side rendering or static site generation (SSG) for React applications to improve perceived performance and SEO. Following React best practices, writing efficient and maintainable code, and implementing performance optimization techniques are essential for building high quality React applications. By adopting these practices and tips, developers can create applications that are easier to maintain, performant, and provide a better user experience. Regular code reviews, refactoring, and staying up to date with the latest React developments are also crucial for continuously improving code quality and performance. Next steps and further learning. I'll provide you some resources here for further learning. First one is the official React documentation. The React documentation provides comprehensive guides, tutorials, and API references for learning React from beginner to advanced levels. Next is the React Fundamentals course. Online platforms like Udemy, Coursera, Pluralsight, or even YouTube offers courses specifically focused on React fundamentals, covering topics such as components, state management, and routing. Advanced React courses. Explore advanced React courses like performance optimization, server-side rendering. I know we just touched it, but there are more courses available, and also GraphQL, with courses available on platforms like Egghead, Frontend Masters, and React Training. Community forums and blogs. Engage with React community through forums like Reddit's r/reactjs, the Stack Overflow, and blogs written by React experts and enthusiasts. Open source projects. Contribute to open source React projects on platforms like GitHub to gain practical experience and learn from experienced developers. I'll also provide some advanced React topics to explore. React hooks. Deepen your understanding on React hooks by exploring more advanced hooks like use reducer, use context, and custom hooks for state management and side effects. There's also server-side rendering (SSR). Learn how to implement server-side rendering within frameworks like Next.js to improve performance, SEO, and perceived loading times of React applications. There's also GraphQL with React. Explore integrating GraphQL with React applications to efficiently fetch and manage data from APIs, improving performance and developer experience. Testing React application, dive into testing React components with tools like Jest and React testing library to ensure code quality and maintainability through unit tests and integration tests. The last, React performance optimization. Learn techniques for optimizing React application performance such as code splitting, memoization, virtualization, and optimization network request. Build real world projects with React. E-commerce website. Build a full-fledged e-commerce website with React, integrating features like product listings, shopping cart functionality, user authentication, and payment process. Social media platform. Create a social media platform using React. Incorporate features like user profiles, news feeds, posting, commenting, real-time notifications, and messaging. Then there's task management app. Develop a task management application with React, allowing users to create, update, and delete tasks, set deadlines, organize tasks into categories, and collaborate with others. Portfolio website. Design and build a personal portfolio website showcasing your projects that you build above, skills, and achievements using React, along with modern design principles and animations. Finally, blog platform. Implement a blog platform with React, enabling users to create and publish blog posts, manage categories, tags, interact with comments, and implement features like search and pagination. We'll be covering some of these in future video series, but for now, these are the steps that you can take to better understand React. Continuing your learning journey with React involves exploring advanced topics, building real world projects, and staying updated with the latest trends and best practices in the React ecosystem. By delving into advanced React concepts, contributing to open source projects, and building meaningful projects, you can solidify your understanding of React and become a proficient React developer. Remember to stay curious, practice regularly, and leverage online resources and community support to enhance your React skills further. As we conclude this comprehensive React development course, we want to extend our sincerest gratitude to you for embarking on this learning journey with us. We hope that you have found this course to be enriching, insightful, and empowering as you have delved into the intricacies of React development. We understand that learning a new technology can be challenging, but your dedication and commitment to mastering React have brought you to this point. Whether you're a beginner taking your first steps into the world of React or an experienced developer seeking to expand your skill set, your enthusiasm and persistence have not gone unnoticed. We'd like to express our appreciation to everyone who has contributed to making this course possible, from the instructors and the course creators to the fellow learners who have shared this knowledge, insights, and experiences along the way. Your collective efforts have created a vibrant learning community where collaboration and growth thrive. As you continue your journey as a React developer, we encourage you to keep exploring, experimenting, and building. Remember that learning is a lifelong pursuit, and each challenge you overcome and project you complete brings you one step closer to mastery. Once again, thank you for choosing to join us on this learning adventure. We wish you all the best in your future endeavors and hope to see you again soon in our future courses. Keep coding, keep creating, and keep innovating.